All right, in this video, we're going to work problems 1 through 5 on the bond pricing questions. This document is available on Canvas. So I'm going to work these questions with the financial calculator here, and then I'm also going to pull up Excel on this side and work. Basically, what I'll do is I'll switch off between using the financial calculator and Excel, so you get comfortable using both. Let's start with number 1. Suppose a 7% in annual terms coupon bond that pays quarterly payments and matures in 8 years is currently priced at $965.60. The face value of the bond is $1,000. What is the yield to maturity? Okay. Recall our time value money functions in the calculator. The face value corresponds with the future value. The coupon payment corresponds with our payment function. The price of the bond corresponds with the present value. I over Y corresponds with the bond's yield to maturity, and N corresponds with the time to maturity. Okay, so in problem 1, what we're going to solve for is I over Y. All right, and to obtain I over Y, what we're going to do is we're going to think of things from the firm's perspective. When I say from the firm's perspective, we're going to think of outflows and inflows from the firm's perspective. So recall, the firm specifies or sets the coupon rate. It sets the face value, and it sets the maturity. The face value and the coupon payment is going to be an outflow, so we're going to have to put negative signs for payment and face value, future value here. The price of the bond, 965.60, is present value. That's going to be an inflow, so we're going to treat that as positive. We're also going to have to adjust the payment and the time to maturity, as well as the calculated yield to maturity that we'll obtain into quarterly payments. Okay, so for problem 1, I have negative 1,000. Again, it's an outflow from the firm's perspective. Negative 1,000 face value. I have $70 coupon per year. Again, that's 7% of face value, so that's $70 per year. I'm going to divide that by 4 because the firm is paying quarterly payments. I'm going to put a negative sign in front of that because that's an outflow, and the bondholder will receive from the firm a $17.50 coupon every 3 months. Okay, the price of the bond is $965.60. Again, that's positive, an inflow to the firm. And we have 8 years to maturity. I have to multiply that by 4 to get the number of quarters in 8 years, which is 32. And then I'm going to compute I over Y, which gives me my yield to maturity, and I get a quarterly yield to maturity of 1.8943%. I multiply that by 4 to get an annual yield to maturity, and I get about 7.58%. So the answer to number 1, the calculated yield to maturity, is about 7.58%. Let's do number 2. Let's use Excel on this problem. What is the price of a $1,000 face value bond that matures in 10 years, has a coupon rate of 7%, and a yield to maturity of 7%? Okay, we don't even have to use the calculator on this one. Remember, the firm is specifying the coupon rate. You can think of the firm coming to the market wanting to sell bonds to get a loan from the market, and they say, we think we're about 7% risky. The market determines the price of that bond, which subsequently affects the yield to maturity, or the actual interest rate that the firm will have to pay on the bond. And if the firm has accurately represented the default risk and the market agrees with it, then the market is just going to buy the bond at the face value. Let's verify that. I'm going to calculate the present value of this bond. The rate is 0.07. That's my yield to maturity, by the way. My number of periods is 10 years. The payment is going to be a negative 70. That's a coupon rate of 7% times 1,000, 7% of 1,000. And my face value is going to be negative 1,000. The type here says you put 0 if you want compounding at the end of the period, which I want. I'm going to close my parentheses, and the price should be 1,000. Good. Okay, so that's number 2. Let's answer number 3. What is the yield to maturity of a $1,000 face value bond that matures in 13 years, has a coupon rate of 8.1%, and is currently priced at $1,008.88? Okay, let's go ahead and use Excel for this problem here. I'm going to calculate the yield to maturity, so I'm going to calculate rate. The number of periods on problem 3 is 13 years. The payment is 8.1% of face value, or negative 81. Now notice in problem 3 I don't specify that the coupons are going to be paid at any other frequency than annually, so we assume if I don't specify that they're semi-annual payments or quarterly payments, these coupons are just going to be paid annually. The present value of this bond is the bond's price. Again, that's positive, an inflow for the firm. The face value is negative 1,000, compounding at the end of the period. You should note something here, that if the bond is priced at a premium, then the yield to maturity will be less than the coupon rate. We talked about that in class. So I'm expecting a yield to maturity slightly less than 8.1%. Let me give you some extra decimals here. All right. And I get a coupon rate of 7.988%. Okay. So problem 3, that makes intuitive sense. The market is willing to buy this bond at a premium, which means the yield to maturity is going to drop below the coupon rate. Okay. Number 4, what's the price of a $1,000 face value bond that matures in 18 years, has a coupon rate of 9% and a yield to maturity of 9.5%? Assume that coupons are paid semi-annually. We're solving for present value. The yield to maturity is higher than the coupon rate, so this bond should be priced below the face value. Let's use our financial calculator for this one. I've got an outflow of negative 1,000 future value. That's the face value of the bond. We're looking at number 4 here. The coupon rate is $90 per year. That's a negative, but I need to divide that by 2 because the payments are paid semi-annually. So I have a negative $45 coupon for each bond paid semi-annually. Again, that's an outflow to the firm. The yield to maturity is 9.5%. That's in annual terms, so I'm going to have to divide that by 2 as well. And I get a semi-annual yield to maturity of 4.75%. And the bond matures in 18 years. I times that by 2, and I get 36 semi-annual periods until maturity. I'm going to compute the present value, or the price of the bond, and I get 957.27. That makes intuitive sense. The yield to maturity is slightly higher than the coupon rate. That means this bond will be priced at a discount. All right, let's wrap up this video by solving number 5. What is the yield to maturity of a $1,000 face value bond that matures in 16 years, has a coupon rate of 5.5%, and is priced at a discount of $915.77? Coupons are paid quarterly. Okay, let's use Excel for this one. All right, so what I'm going to do here, we're solving for yield to maturity. In number 5, I'm going to say equals rate. The number of periods, the bond matures in 16 years, so 16 times 4. Let me come down here. 16 times 4 is going to be 64 quarterly periods. Let me also, while I'm down here, divide the coupon rate by 4. Or divide the coupons by 4. The coupon rate is 5.5%, so the coupon is $55. I'm going to divide that by 4, and I get a quarterly coupon of $13.75. Okay. Of course, I'm going to solve for the yield to maturity in problem 5, so that's going to generate quarterly yield to maturity. So up here, I'm going to say equals my rate. My number of periods is 64. My payment is negative $13.75. My present value is $915.77. My future value is negative 1,000. We're having compounding at the end of the period. Hit OK, and I get a quarterly yield to maturity of 1.5854%. I'm going to multiply that by 4 to get an annual yield to maturity, and I get 6.34%. Again, the bond is priced at a discount, so my yield to maturity should be greater than my coupon rate.